Let's find antiderivatives involving exponential function, base e. So rule 8.4 is what we're going to use. I'm going to go ahead and copy this. And we'll go over the examples down on page 3. Copy the rule over here. Well, maybe we should talk about this rule a little bit, okay? What you know already is, I'll add a page right here. If I ask you to take the derivative of e to the x, we know that is e to the x, right? We know that. But if I ask you to take the derivative of e to the 5x, what's that going to be? Remember, using the chain rule, we have to do e to the 5x times derivative of 5x. So that comes out to be, hold on, 5 e to the 5x, right? Another very similar example, what about e to the negative 7x? That is going to be negative 7 e to the negative 7x. So the antiderivative is about going backward. So what if I tell you that the function is 8 e to the 8x? How would you find its antiderivative, which means what goes in this parenthesis? And that is going to be e to the 8x, and technically I can have a plus c there, right? So what's the rule? What's the rule? The rule is first talking about the derivative rule. We write down that exact same function expression, and then we multiply by the coefficient of the exponent, right? If it was 5x, I multiply by 5. So what we have to do is we have to go opposite way. What's the opposite of multiplying? Dividing. That's why the rule for this exponential function is if you have e to the ax, you're going to write down e to the ax, but remember to divide by a. Remember to divide by a, or multiplying by 1 over a. So because the opposite of multiplying is dividing, that's why we have to divide by or multiply by 1 over the coefficient of the exponent. So using that rule, I'm over here, okay? So this is equal to e to the 4x power divided by what? 4, and that's it, plus c. Next one, it's so easy, right? Isn't it so easy? Well, if you may want to check it, because you're like, this is too easy, I don't know if this is true. If you want to find the derivative of 1 over 4 times e to the 4x plus c, what you need to do is multiply this 4 times 1 over 4. That gives you 1, right? So you can, okay, I'll write it. You can say that is 1 times e to the 4x, and this plus c, derivative of a constant, is just 0. So because it's coefficient of 1, I don't really have to write 1 in front of it. So let's see what we just got. Is this the same as what was in the integral? Yes, it is. So we got it right. So it's super easy. You write that term. You don't go up on the exponent like the power rule. For these exponential functions with base e, you just write the function and divide by the coefficient of the exponent. So for the next one right here, what you're going to do is you're going to just say this is equal to e to the negative 3x power divided by what number? Negative 3. And that's it. And you can do plus c if you, we need to put that part. Well, if you want to write this a little bit prettier, I guess we can write it as negative 1 over 3 times e to the 3x plus c. And the reason I was able to send that e term to the bottom of the fraction is because it had a negative exponent. But both are fine. Both are fine. Okay? And you can check your answer, but I guess I'll skip it for right now. Okay. Next one. I need to do the same thing over here. This is equal to e to the 1/2 over x. You write the same thing, but then you must divide this by the exponent 1/2, and you put that plus c. But listen, dividing by half is same as multiplying it by 2 over 1. Okay, dividing it by 1 over 2, okay, is the same as multiplying by its reciprocal of 2 over 1. So instead of saying this nasty dividing by 1/2, I'm just gonna multiply this by 2 and say my final answer is 2 times e to the 1/2 x plus c. And that is how you can find the antiderivative of exponential functions.